A very good morning. Happy day to all. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, here before you to present the next topic on the lecture series, what we have been seeing for the past few videos. The next topic is going to be about the Kirchhoff's laws. Electric circuits and electron devices is the subject what we are going to deal with. The next topic is going to discuss is about the Kirchhoff's law. So what is Kirchhoff's law? We'll just move into the subject. Yes. So we are going to see about three different parts in this presentation. One is the history of Kirchhoff's law. Second one is what is the introduction and what you're going to deal with. What is this Kirchhoff's law? And next is what are the different types of Kirchhoff's law? Okay. So what is the history behind the Kirchhoff's law? The Kirchhoff's law is nothing but the one who is called as the Gustav Robert Kirchhoff, a German physicist, described two laws that became central to electrical engineering in 1845. These laws were generalized from the work of George Ohm, who invented the Ohm's law. It can also be derived from the Maxwell's equation, but were developed prior to the Maxwell's work. What is about the Kirchhoff's law? This explains a pair of laws stating general restrictions on the current and voltage in an electrical circuit. How does this happen? The first of these states that at any given instant, the sum of the voltage around any closed path or loop in the network is zero. The second states that at any junction of paths or node in a network, the sum of the currents arriving at any instant is equal to the sum of the current flowing away from it. What are the different types of Kirchhoff's laws? As we all know, the types of Kirchhoff's laws is classified into two. One is based on the basic parameter, the current. Second one is the second basic parameter of voltage. When we are going to deal with the voltage, it is called as Kirchhoff's voltage law. When we are going to deal with the current, it is called as Kirchhoff's current law. So what is about Kirchhoff's current law? The analysis with Kirchhoff's current law is called as the nodal analysis. What is about Kirchhoff's current law? Kirchhoff's current law is sometimes called as the Kirchhoff's first law or Kirchhoff's junction rule. Along with Kirchhoff's voltage law, make up the two fundamental laws of electrical engineering. It is going to show about the Kirchhoff's current law. KCL helps to solve unknown when working with electrical circuits. Kirchhoff's current law, with the addition of KVL and Ohm's law, will allow for the solution of complex circuits. What is this Kirchhoff's current law? Definition that will help in understanding the Kirchhoff's current law. A Kirchhoff's current law is nothing but a junction is any point in a circuit where two or more circuit paths come together. That is called as the Kirchhoff's current law. So, a junction in any point in a circuit where two or more circuit paths come together is called as the Kirchhoff's current law. So here gives the example of Kirchhoff's current law. There is an voltage source, three resistances, and a junction point. So in a junction point, the sum of all the currents is equal to zero. That is the another statement of Kirchhoff's current law. So what is the next statement of Kirchhoff's current law? So Kirchhoff's current law generally states the algebraic sum of all currents entering plus and leaving minus at any junction point in a circuit must be equal to zero. Here you could see there is four incoming and outgoing paths totally, and there is one junction path. That the current are termed as I1, I2, I3, and I4. So the equation according to the Kirchhoff's current law is given by summation I of n is equal to I1 plus I2 plus I3 plus I4 is equal to 0. This equation or this law can also be restated as the sum of the currents into a junction is equal to the sum of the current out of that junction. So this is what an important law which is called as the Kirchhoff's current law. So this can be stated as the algebraic sum of all currents entering plus and leaving minus at any point in a junction in a circuit must be equal to 0. This is explained with the equation over here. I1, I2, I3, I4, and I5 at a junction point is equal to 0. That is I1 plus I2 plus I3 plus of minus I4 plus I minus of I5 is equal to 0. Here the three currents entering the node I1, I2, I3 are all positive in value, and the two currents leaving the node I4 and I5 are negative in the value. So the equation becomes I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. So with this, Kirchhoff's current law will be going into for another type of analysis, which is called as nodal analysis. That we will be continuing in the next video. So thanks for watching.